have you ever dropped your phone by accident and watched it hit the ground with a thud? That's not just gravity at play. It's actually a brilliant example of energy conversion in action. Hello everyone. Let's dive into the fascinating world of how stored energy transforms into motion. In physics, we learn that energy doesn't just appear or vanish, it converts. And one of the most common transformations is the change from potential energy, the energy of position, into kinetic energy, the energy of motion. Think of a stretched bow, a compressed spring, or even water stored at height in a dam. These systems store potential energy that's ready to transform into movement. This transformation obeys the law of conservation of energy. Energy may shift from one form to another, but the total always remains constant. Imagine a stone held high above the ground. At that elevated position, the stone possesses gravitational potential energy, energy due to its height. Now, the moment we let go of the stone, that potential energy begins to convert into kinetic energy as the stone gains speed while falling. As the stone hits a nail placed on a surface, its kinetic energy is transferred to the nail, pushing it into the wood. That's mechanical work being done. This entire process is a direct conversion from stored potential energy to kinetic energy and finally into useful mechanical work. It's a simple yet powerful example of how gravitational potential can be effectively harnessed to perform work in the real world. Picture a mechanical watch with its spring tightly wound. This compressed spring stores elastic potential energy ready to be released. As the spring begins to unwind, this stored energy transforms into kinetic energy that powers the movement of tiny gears inside the watch. The hands of the watch move smoothly and continuously, all driven by this kinetic energy from the spring. What's amazing is that no external force is needed to keep it running. The energy was already stored inside. This is a perfect example of how elastic potential energy can produce controlled and functional motion. So what exactly is evaporation? It's the process where liquid particles at the surface gain enough energy to break free and escape into the air as gas. Unlike boiling, which happens only at a fixed temperature, evaporation can occur at any temperature, even on a cool day. But here's the twist. Only the most energetic particles near the surface manage to escape. And when they do, they take that energy with them. What's left behind? A liquid with less average energy, which means it cools down. That's why evaporation doesn't just dry things, it also makes them feel cooler. This is why scientists call it a surface phenomenon, because it all begins right at the top. Let's take a closer look at a compressed spring. When a spring is squashed, it stores elastic potential energy due to its deformed shape. Now, the moment you release the spring, this stored energy quickly transforms into kinetic energy. If there's a ball resting on top of the spring, it gets pushed upward as a result of this energy transfer. This upward motion is clear evidence that the compression was holding real, usable energy. In simple terms, this example shows how energy stored in a compressed spring can cause actual, visible movement. Whether it's a stone falling under gravity or an arrow released from a bow, one thing remains constant. Potential energy is never lost. It simply changes form, most often into kinetic energy. We see this in spring-based toys, catapults, and even massive roller coasters, all harnessing stored energy to create motion. This beautiful exchange of energy is what makes physics so powerful. It explains how forces are stored, transferred, and used. The law of conservation of energy tells us that total energy always remains constant, even as it shifts from one form to another. By understanding these concepts, we can design smarter, more energy-efficient machines and systems that use energy wisely and effectively.